Hello everyone, my name is Muzammil Ahmed. Today I'm super excited to share my project and production ready product called Chatalytics. So, what is Chatalytics and what is it used for? So, let's take here an analogy, right? Suppose you're a businessman and you receive data from multiple sources. It could be a software business or it could be a restaurant business, and you receive data such as order details, payment details, and all of that, and you most likely will store it in a SQL database. Now, as a business owner, you want to make data different driven decisions and decisions that are backed up by data. But to get info on data, you have to first ask your company's data analysis to go query your SQL database, then he will receive that information, then he will send it to you. It's a long chain of process and it takes a huge amount of time. And this is a real big problem because time is the greatest asset of a businessman. Now, how can we make this process simpler? Well, this is exactly what Chatalytics solves. Chatalytics allows you to chat with your data in natural language and receives responses in 5 seconds, and even custom generated tables, line graphs, and bar charts. And I'm super excited to demonstrate it to you. So yeah, let's get right in. So now how does this whole system works? Well, in this system, we've actually used an agentic approach. And agents are nothing but chatbots like large language models such as ChatGPT that are tuned, you could say instructed to work for a specific purpose, and they have access to a specific set of tools that they can utilize to get to forge an answer to the use for the user query. And here in this agent, we have used models from OpenAI ChatGPT, right? And our agent can be connected to any sort of data source. It could be SQL, it could be PDF, it could be CSV. But in this over here, we are going to be using SQL databases, right? Now, as you know it, your like normal chat GPT cannot access your personal documents or communicate with the SQL databases. But so that's where the tools come in. So we can talk to our SQL database by using a toolkit that allows us to create SQL queries and run them on our SQL database. So what ChatGPT does, it takes the user query, it turns it into a SQL query, then using the tools it has been provided, it runs the query on the SQL database and gets the result. Pretty awesome. But with this approach, I think you can already see a few problems. The first one is that what if the user query is like a super complex query that requires a multi-step query process? Like a query that's so complex that out of the box ChatGPT cannot forge that sort of query, and will probably fail at this point. How can we provide it additional information that if you inquire a user query that is something like this, it's a little complex and there's a something like this, then you can use a SQL query. It's relative SQL query will look something like this. And next problem with this approach is that ChatGPT has to create a whole new SQL query. You take the user query, convert it into a SQL query, and run it all from scratch. And this is really bad for the speed performance. And with production grade products, speed is the biggest factor in everything. So how can we increase the speed of our agent? How can we do that rather than it having to create SQL queries from scratch? How can we provide it with a set of common user queries and the relative SQL queries, so it doesn't have to generate one from scratch but can just like refer to the pre-existing ones and do that? Well, that's exactly another feature that we have added to our whole system, that is basically a safety net. So if a user query is pretty difficult for the agent to understand, or and a performance boost, the so it can deliver results quickly and more efficiently. So how does that work? Well, firstly, we create vector embeddings of the common and difficult queries. So common queries to increase the performance and difficult queries to act as a performance like a safety net. So there it will be the user query and its relative SQL query, and we have created these vector embeddings using open source model from Hugging Face. Next, we have stored them in a vector database, and this database is from FIS, and it's a FIS database by Meta. So we create all of these vector embeddings and we store them in a database. Now you must be wondering that if it goes through each and every set of query and its user query and set of SQL query iteratively through the whole database and try to find like a common or one that can refer to, that will take way too long. It will be actually a performance down if you think it that way. But that's exactly the reason we are using vector databases. So let's take an example here. As we humans use a dictionary, we do not go through each and every word and see if it matches the word we're trying to find the meaning for. We filter it out using the some sort of filters, word filter and second word filter, stuff like that. Just like that, that's how a vector database works as well. And you could just multiply this analogy by 10, so it can get any result super fast, super quickly, and it can give anything that's relevant to the user query in a snip. And we get that by using something called semantic similarity search, which just retrieves everything from the vector database that it finds relevant to the user query. Now, the chat GPT model has some reference point, so it can make up things faster, it can make the SQL queries faster, and it has a safety net if there's some sort of hard query by the user. uh, now now with this, we have the first half of our process done, which is creating the query and running the query. Now how will we get the results from the query and display them in natural language? So for that, what we can do is that we will call our agent again, right? So the results that we get from the SQL database, we're going to forward those results to our agent again, and we're going to instruct it to convert them into natural language. And with this, we are also going to provide it with another set of tools which it can use to create tables, bar charts, line graphs, stuff like that, right? Now after it has done all gotten and created all the visualizations, it can just give a final response, a natural language and graph and everything, which sums up this whole workflow diagram. So from here to here, that's how everything will work in our system. So to get started, you just have to connect your database, and here's actually a database of a real restaurant. So this is going to be some really exciting data. And after it has been connected, we can start querying it. So we can ask a question like, what were the top 5 best-selling items in December 2023, right? And we can ask this simply, and now it's going to be processed, and we can actually look at what's happening in the background by going here. And over here you can see it queried the database with this query over here, and this is the result that it received, and it converted this result to a natural language response, right? And if you go back, here you can see the simple and nice looking response that it generated of 5 best-selling items and all of them like this. And now we can even ask follow-up questions such as generate a bar graph or graph with this data. So we can ask this, and this system has its like own built-in memory and stuff. So it remembers the previous questions that you asked. It remembers what it said and everything. And you see, because of this memory, it was simply and quite fast. Was able to generate a bar graph. Now that was it for how everything works, and I hope you all learned something new today. And this was basically the whole workflow diagram. And we use so many technologies ranging from embedding models from Hugging Face to uh, Fire's Vector Store from Meta, then Chat GPT from OpenAI, SQL databases, and yeah, even use LangChain to connect and interface everything together, and so many things. And yeah, if you would like to see more videos like this and really enjoyed this video, please make sure to subscribe and like this video. It would really mean a lot to me. So yeah, see you in the next video. Bye bye.